right? He don't want to use this formula or the tables or that. What he do is that he use this one. Okay, he use the formula. Okay, what is formula? You know Azman or Azman. Muhammad or Azman. Okay, he use this formula. Okay, what he did is that CF, right, divided by 1 plus K power of 5, okay, minus with initial investment, okay, equal to 0. Okay. So CF is 14,000 divided 1 plus K. 1 plus K is 1 plus IRR power of 5 minus with, okay, right, and then shift the one to the left. Okay, 42,000 equal to 14,000. Okay, 1 plus IRR power of 5. Okay, and then this one can be changed, interchangeable, right? 40,000 you can change downward. This one you can change upward. Okay, so 1 plus IRR power of 5 equal to 14,000 divided by 42,000. Okay, right? Okay, can I go on? Okay, how much you get for this one? 0.3333 until infinity, right? So, okay, we continue. Can I just erase this one? So 1 plus IRR power of 5, okay, equal to 0.3333333333. Okay, okay, right? So what you do is that you eliminate the power of 5. Okay, just square roots of 5, right? Okay, so this one is 1 plus 1 IRR equal to how much? Square root of 5, 0.8027. Okay, right? So then you just shift 1 to the right. Okay, shift 1 to the right. IRR equal to how much? Minus 1. Okay, 0.8027 minus 1. You get? Yes? 0.1197. Okay? Then you just, because this is negative and it's okay, eh? Whether it's negative is okay. So actually this is 19.7%. Okay? This is using formula. Okay? Ignore the negative figure. Okay? IRR is okay. You have a negative figure, it's okay. Right? Okay? Because this is actually 19.7%. Okay, this is using formula. This is your friend, Muhammad Nur Razman. And he don't want to use the table. He said he want to use this one. Okay, so I just tell you how to use this one. Right, now, what about this one? What about the second one? This one is simple, right? If you have to use interpolation, because this is using only if you are using formula, CF is only 1, it's only 14,000, right? But this one you have 28,000, 12,000, 10,000, 10,000, 10,000. So how do you want to find this? You have to use 1 by 1. You have to test 1 by 1. Okay? So basically, it's the same. You test, for example, 1 positive, another 1 negative NPV. Okay? You test, okay, for example, test only at 15%. Okay, how much you get? Positive NPV. And then test at 25%, you get a negative NPV. So then you interpolate between these two figures. You will get this in the middle, 21.7%. Okay? The same, you must have 1 positive NPV, 1 negative NPV. You must find the negative NPV first. Okay? So because sometimes, I'll show you after this, why we must find one estimate. Okay? So can I continue on? Yes, okay, continue on. Net present value profile. Okay, net present value profile. Now, sometimes when you want to evaluate between two projects, for example A and B, okay, you use NPV. You use NPV, you accept project A, okay, and then when you use IRR, you accept project B. So actually you are confused. Using NPV, accept A. Using project IRR, you want to accept project B. So how this thing can happen, right? So basically, now we are looking at this net present value profile. So net present value profile is actually a graph, right, that depicts project NPV for the various discount rates and provide an excellent means of making comparison between projects. Okay, now look at example. To prepare NPV profile for various companies, project A and B, the first step is to develop a number of discount rate NPV coordinates and then graph them as shown in the following table and figure. This is the following table and figure. Now the first one you do is that you look at the discount rate if the discount rate is 0. Okay, discount rate is 0, you don't have to discount. Okay, you just take your outflows and inflows, then minus altogether, you get 38,000 and 25,000. And then you use discount rate at 10%, okay, you get 11,071 and also 10,924. This one you have already calculated when you want to find the NPV, right? Okay, and then this is your IRR. Okay, IRR at 19.9%, your project A will be 0. Okay, 21.7, project B will be 0. This is when you want to find the IRR, right? So you just depict this table. Okay. So when you get this table, you can always draw this graph. Okay, you draw this graph. Now let's see. After you have drawn this graph, you can see that this is the equilibrium point for the NPV. Okay, equilibrium point for NPV, or the crossover, what we call it, crossover for both NPV. So this NPV for project A and project B at this equilibrium point will be the same. Okay, it will be the same. It will be 10,000. It will be 10,000. Project A NPV 10,000. Project B NPV also 10,000. Okay, and the rate is 10.7%. Okay, now if you look at this graph, project A before 10.7% is better than project B. After 10.7%, project B is better than project A. And that's why sometimes when you calculate, okay, using NPV and also IRR, you have different results. One you calculate, okay, NPV you calculate, you accept project A. Okay, but when you calculate using IRR, you accept project B. Okay, so if you want to choose which project you want to accept, you look at the rate. Okay, you look at the rate. If the rate is lesser than 10.7, you accept project A. If the rate is higher than 10.7, you accept project B. This is after you have depict this graph. Okay, depict this graph. After you have drawn this graph, then you can find which one is better. Right? So this is net present value profile. Okay. So this will actually say that if the IRR is 10.7 and below, we choose project A. If higher, then we choose project B. Okay. Now we continue on to the conflicting ranking. Okay, conflicting ranking between two or more projects using NPV and IRR sometimes occur because of differences in timing and magnitude of cash flows. Right. This underlying cause of conflicting ranking is implicit in assumption consisting of the investment of intermediate cash inflow and cash inflow received prior to the termination of the project. Now we look at the conflicting ranking because of the reinvestment opportunities that we have. Okay, so when we receive the cash inflow, right, for year 1, year 2, year 3, year 4, year 5, the cash inflow actually we can use to reinvest back again. Is it correct? Yeah? we can reinvest back, right? In other investment or in other business to gain profit. Okay, so this is why profiting ranking is actually occur. Okay, so NPV assume integrated cash flow are reinvested at the cost of capital, whereas the integrated rate of return invest at the IRR. So that's why we have different and conflicting ranking. Okay, because NPV will reinvest at cost of capital. Okay, NPV. But IRR we reinvest at IRR, investment rate. Okay, now we look at this example here. Okay, now let's say we have the cash flow, right? 52,000, 78,000, and 100,000. Okay, so this is 52,000. Okay, we receive in year 1. So if the project is 3 years, we still have 2 years to reinvest this 52,000, right? Okay, because we receive in year 1, there are still 2 more years ahead. So this 52,000 can be reinvested for 2 years. Okay, and then we just look at the net present value. Net present value says that we will reinvest at the cost of capital. So we will invest at 10%, right? Cost of capital. So we use 10% future value to factor. 10% we get 52,920. Okay. So also the same for the second cash flow, third cash flow. Okay. Except that for this one we just change this one. So because second year, number of years that we can reinvest is 1 year. If we receive in third year, there's no more years that we can invest money, right? So the differences is between NPV and also the IRR is that we reinvest this one, the NPV at 10% cost of capital, whereas IRR we will reinvest this one at 15% IRR. Okay, so we will have different value here, 248, and then this one is 258. Okay, so this one is greater, right? This one is greater. Okay, this one is greater, 258,000. Now, now if you look at, if you want to find the net present value here, okay, so actually NPV at 10% is 16,867 compared to this one 24,230. Do you know how we get this one? Do you know how we get this one? 248,720. We discount it. Discount it for 3 years. How much you get? Okay, 248,720. You discount it for 3 years. Then you minus with 170. Do you get 16,867? How much you get? Okay, 16. Okay, what about second one? So, do you get this figure? No, you didn't get this figure because you're using table, right? So you get 16,000. Okay, but if you are using formula, then you can get this exact figure. So this is also the same. And this one also you discount at 10%. Don't discount at 15% because you want to find NPV at 10%. Okay? Except that this is already being reinvested at 15% base rate of interest IRR. Okay? So basically, after this you find your internal rate of return. This one is 15%. This one is 13.5%. Okay? Yes? We calculate IRR with the same method lah. IRR 15.5. 15% this one we already know because we are using future value of we are using the investment rate of 15%. Okay. Okay. Any question? Any question? Is it difficult for you? Is it difficult? Is it difficult? Not difficult, right? But you have to practice. You have to practice because understanding is different. You listen okay, read okay, but you have to practice. Then you understand better. And practice is way. Okay? Because this is also time consuming. And using this all the NPV is also time consuming. So you have to practice. Now. So the rule that we are using here is that, and when we have the probability ranking, is that when you have a lower early year cash inflow, okay. So and then you have also low discount rate, you will prefer or you accept the project. Okay, but you have high early year cash inflow but a low discount rate, you do not prefer or you reject. Okay, and then if you have a lower early year cash inflow but a high discount rate, you do not prefer. But when you have a high early cash inflow and high discount rate, you prefer. And you can always remember this one only. High prefer. Okay, high discount rate, high early years, you prefer. You remember this one. The rest is the vice versa, right? Okay. High discount rate at a higher early year, you prefer because sometimes because if you receive higher early cash inflow and then at a higher discount rate, you can invest that money, right? At a higher discount rate, so it's preferable, right? So you receive, for example, 50,000 compared to 10,000. And then that 50,000, you have a higher discount rate. It's better, right, for you to reinvest. Okay, reinvest it. So that's why we prefer. Okay, so we just remember this one. High discount rate at a higher early cash inflow, we prefer. Okay, the rest is the vice versa. Okay, right. So the concept is that when you receive early higher cash inflow at a higher discount rate, it's better because you can reinvest that money that you receive early, which is the big amount, right, at a higher discount rate. Okay, all right. So which method is preferable? Which method is preferable? NPV or IRR? Which method? IRR. Okay. Theoretically, NPV is better. Yeah, NPV is better. And for students, we use NPV. Okay, every day and you learn NPV. Okay, because it's assumed that intermediate cash flow are invested at the cost of capital. Okay. Whereas IRR assume that they are invested at the internal rate of return. So that's why theoretically this is better. NPV is better. And then certain mathematical properties may cause a project with a non-conventional cash flow to have a 0 or more than 1 year IRR. Sometimes, for example, certain project does not have one initial investment. Okay, one cash outflow. It has 2 or 3 cash outflow. Okay, first year it has a cash outflow, okay, and then maybe 3 years after that, another cash outflow. And then 5 years after that, another cash outflows. So it's difficult for you to find the internal rate of return, right? Because it has 2 or 3 cash outflows. So that's why NPV is better when in terms of theoretical. Okay. Okay, despite its original superiority, however, financial manager prefer to use the internal rate of return as the basis of calculation, because internal rate of return normally when we are in the industry, right? It's better for us to say 10% compared to RM 10,000. Okay, right? RM 10,000 out of how many percent, right? So better in the industrial, in the practical industry, for the business managers or for the financial managers, it's better for them to use the IRR because it gives answers in terms of percentage, in terms of rate of return. Okay, 10%, 20%, 30%, right? It's easier to actually say 20%, right? And then people can understand easily, right? 20%, 10%, 3%, right? So that's why in terms of the practical, right, in terms of the practical industry, or in terms of the usage of the IRR in the practice world, this is preferable, internal rate of return. Finish. Okay, we have finished for chapter 9. Okay. So basically, normally I take 2 hours, but this one because I express like yeah. So what we do now, maybe we don't want to finish early, but we can just do some exercise.